Good morning, all of you. Thank you, Dr. Ramesh, for joining us. We welcome you, sir. It's indeed a pleasure to have you here.
Pleasure here, ma'am. How are you?
Yes, sir. Hello. Am I audible, sir?
Yes, ma'am. Am I audible too?
Yes, sir. Yes, sir. Loud
Good
and
morning.
clear.
Nice to see you.
Same, sir. So nice to see you after a very long time.
Ma'am. So we'll
Yeah.
just wait for the other panelists, right?
Yes, sir. Yes, sir. Thank you.
Thank you. So by then, can I switch off my camera or something?
Yes, sir, you can. And whenever you want to, you can switch it on. Yes, sir. It'll be
Thank you.
good if I have you on all the time, but as you wish.
Just when the panelists join, I'll be on. Just
Okay,
thank you.
thank you. Thank you, sir. Good morning, one and all gathered here. We'll wait for a few more minutes for all our panelists to join here, and then we'll take off from there. Thank you so much for being here. Good morning, Raghav, sir. Good morning, sir. இப்பதான் ஆரம்பிக்கிறோம். இப்பமா welcome, Manu sir. Thank you so much for being here. We'll just shortly start in a minute.
Hey, hi, welcome everybody. I think I was having a challenge in the password login. Sorry.
Yeah, yeah. Now you're very much in. Thank you so much for being here.
Yeah,
Yeah,
thank you. Yeah.
welcome. We'll just wait for a couple of minutes
Sure,
and
sure.
yeah. Good morning, sir. Yes, sir. Oh, sir, you've joined with the panelist, sir.
Good morning, Miracle. We may start the session, Miracle. So that there are 200 around 200 participants have joined. We can start the session.
Yeah. Noted, Raghav. Sir, just that like we are not able to see CEO sir here, right? In the panel list, and he just called and told like he's not able to unmute himself. But I'm not able to see him here in the panel list. I'll just make a quick call to him. We'll just start shortly. Sorry, hold. Good morning, all of you who have gathered here. Looks like a technical glitch from one of our panelists' side. We are just waiting for Mr. Srikanth, the CEO ICT Academy. Let us start meanwhile, and like when Sir joins in, we'll have his inaugural address taking place. So, very good morning to all of you once again. Sometimes the hurdles aren't really hurdles at all, right? We see challenges in life, but they are not really challenges, they are welcome challenges and tests. We have to view it. So, at ICT Academy of Tamil Nadu, we extend a very warm welcome to all the leaders and the going to be leaders who have gathered here this Monday morning. It's going to be a great week for us, starting with the note on the uh, Leaders Talk Series, Thought Leaders Talk Series, the TLTS. It's an immense pleasure to host all these eminent people from the industry, Mr. Madhu, Dr. Ramesh, and Mr. Rajadurai, and Mr. Vipin Karana to be here with us. We have the visionary leaders of ICT Academy here. Mr. Raghav Srinivasan, Srikant sir is also in. And we have Mr. Ganesh Karthik, Mr. Suresh, Mr. Venkatesh, Madam Akila, Madam Aruna, Mr. Naren, Mr. Suresh. So many, the state heads, the domain heads, all the team players. We have been doing an incredible job here at ICT Skilling India and making India a better skilled nation. So, Srikant sir has been a forerunner, making many impossibilities come true. He has always been a very visionary CEO, and we're waiting for him to deliver the inaugural address. Srikant sir, please. Looks like a glitch from his side. Like we'll move on with the panelists. Um, Yeah, Madhu sir, I'll just give a very brief introduction about Mr. Madhu. He is the Chief Growth Officer and the Chief Investment Officer at Garuda Aerospace Private Limited. For all the young people who have gathered here, their brand ambassador is MS Dhoni. So they have a very great person roped in with them. He's been doing an incredible job and very recently authored this wonderful book called Sparks, and he's making ripples throughout India and even in the other countries, I should say. He had a great, very great blogger. It was such an inspirational book, and he's been doing an incredible job. He's The Sparks is an intellectual nourishment. It's a collection of short stories and other various stages of life. And the book is tailored in a first person perspective of various walks of life, where the author gives a punchline or a moral from the perspective of the reader in what way the user can utilize this knowledge in their development. So, not only in the walk of life, this man has made a mark in the drones as well, I should say. So it's a pleasure to have you here, sir. The stage is all yours. Thank you.
Yeah, good morning, everybody. Thank you, an ICT team, for this opportunity. I thank the entire management and the participants who have come here. Yes, I'm the Chief Investment Officer of Garuda Aerospace. So I have taken the company from a $10 million to an IPO. So this year, Garuda Aerospace is going IPO, and I'm the one who is going to do it. And eventually, yes, our brand ambassador is Mahendra Singh Dhoni. And since 2 days, people have started asking me IPL tickets. So I do not know why, but then now I understand why people are talking to me. So with this, I'll start my small presentation. Something interesting which I thought I will show you. Is my screen visible here?
Sir, very clear.
Yeah. So today, I'm going to talk about drone ecosystem and various business and career opportunities available in the sunrise sector. So drone is a very niche area which is emerging and still very nascent in India, unlike other developing countries. And if you notice very well, now the drone regulatory body has also made some changes, enabling various small and medium-sized players and also corporates to enter this sector. So just a background, I'm an author. I actually pushed myself to become an author. I'm an angel investor in about 9 startups. I'm also the co-founder of Startup Tales. I've done a zero to IPO once earlier, and this is my second instant. I also do small investments into which is with various instruments, which is into debt as well equity. I'm also on a board member of a couple of other firms. So this is about me as a person. So let me get into the fundamentals of the drones. So how we started this was, normally, we are a bunch of people where we started talking about solving unsolved problems. So that's where the startup mindset actually comes. So we were able to find the demand and the gap even before we even started the startup. So that's where today we are, the robust startup, which is actually getting into this, agriculture Kisan drone segment, where we are disrupting the $3 billion market, because we are the only one which has found out there are several business models which can be adopted, having an open mind. So today, we are in the B2B market, we are in the B2C market as well as in the B2G market. So how we have moved from a product manufacturing company to a service oriented company towards a technology company. So during this period, we have also developed various kind of drones, and without experimenting, having failures, having burnt money here and there, we were not able to achieve our milestones. But today, we would say we are the most sustainable company in the Indian drone segment. So just to give a background, we are very strong in the drones sector with regards to agriculture. In fact, we were the only one to spray more than 1 crore acres of trials, and where we found out that the drones can be used for various applications in terms of crop spraying, plantation, livestock management, avoiding plus crop monitoring over there. So normally, if you notice in your villages and towns, during cultivation you will not get manpower at all. So that's the biggest challenge which we faced, and which is where the drone is coming to help. And also because of the inefficient manpower availability, you see a lot of crop loss, and plus there is an unstructured pattern of spraying the chemicals. So we were able to find out that if we use a drone and we are able to bring the precision spraying techniques, we are eventually able to increase the yield of the crop. Today our drone spraying mechanism is actually increased close to 35% of the yield. So some of the the value added services from the drone spraying is that where you use 5 liters of pesticides, we use only about 500 grams of pesticides. So we are a part of the UN SDG drones, where the usage of pesticides and water has actually come down, because of which so farmers and the fertilizer players who are actually spraying with their hands, they don't get affected, and through which we are saving a lot of money for the health sector. Now, in terms of where drones are used, if you see the simple chart, where they use 200 liters of water, we use only 10 liters. Where they use more than 30 to 45 minutes of a breakdown time, we complete per acre in an entire 3 to 5 minutes zone. So this is a simple calculation where a drone is actually disrupting the agriculture market. Now, when I compare and move towards the industrial sector, okay, apart from agriculture, there are various applications. So we are the only ones where we are doing the drones for the railway, the metro. So our drones are also used by the Chennai Metro Rail, where we do a lot of inspection for the bridges as well as the structural integrity. So today you see that sometimes when you do a structure, people do manual inspection. They use various civil engineering techniques to check the strength of material. But today we have incorporated the entire technology into a drone, where we do the entire monitoring, structural integrity of the bridge is being taken care. Plus, we also get a real-time analysis, where the decisions taken by the maintenance engineers are fast. So we also do a video analytics tool, wherein we are able to see around I would say around 10,000 images per minute are being scanned to see if there's any cracks or if there's any anomaly. So in fact, basically where sometimes you have structures which are more than 20 meters and 30 meters, which is where the drones come in use. And also with the use of a drone, we are able to do many under inspection bridges. So this is where we are. Plus, you also get a large amount of quality data, which we are able to have an image processing team, which we are able to analyze and then give a structured output to the end user. Drones in terms of telecom sector, normally earlier, what they used to do is that between one tower to another tower, they use at least around 4 to 5 years. They take 4 to 5 hours with at least around 7 to 8 manpower to put a line. I would say a simple telecom wire. But today we are able to do at least around 6 to 7 towers within an hour. So that's where the drones are being used. So we have got a large amount of MNCs in this sector who are actually subcontracting their works to us, and we have a separate telecom team which actually does this job as a service. Now, if you see here, more and more, once we do the installation of this wire, we also get into the project monitoring of the health check of these towers as well as the buses into the system. If you see in terms of the industrial sector, we use a lot of drones in terms of inspection activities. Some of the drones are used for the boiler inspection as well as the pipeline inspection. Of late, various civil engineering companies have also started taking drones for the tunnel inspection. So we are very, very strong in the chimney, in the chimney inspection. In fact, normally when you do a shutdown, that's where they will be doing the chimney inspection. But our drones are able to use and conduct experiment and inspection while the plant is on. So that's where we have developed the first non-destructive drone where it can be used during live wire. So this is where we are, and this is a big business for us. In fact, there are around close to 20,000 chimneys across India, and we have only captured 5% of the market share. Similarly, the same drones are being used for the thermal inspections of the solar panels, so which is a big business as well. The same drone can be also used for the windmill inspection to actually check the motors the conditions over there. So when we take the thermal scanner and the multispectral camera and we use it on the NDT drone, we are able to get different anomalies like the different colors like the green, yellow, and red. Based on which we will be able to get an output, which we are sharing it to the maintenance engineers of the plant. So these kind of anomalies in the solar inspection, which is on the left hand side below photograph, you will see that there is a red color patch over there. So these are the patches which shows that this requires either a crack inspection to be done, or there are so much dust so that you're not getting the required output. So the solar output is not coming out from these panels. So that's where the maintenance engineers of the solar panels go there and they do the inspections over there. Now, if you see there, we have advanced photogrammic techniques. Some are the structural damage assessment. All these softwares are in-house, where we have a separate team which is building it as well as upgrading it. So the biggest the business coming out from the drone inspections are your mining inspections, your entire pipeline inspections, as well as the crop the monitoring inspections. These are the main big businesses which is coming out as a service model. Now, in terms of various growth for the businesses and the vendors and the ecosystem players, what's happening is that there are India being an emerging market and which is about to become a $7 trillion economy. Various foreign international firms are now coming to India. So you will see a lot of joint development activities happening for technology transfer and parts. Some of the technologies which we don't have in India, we have started working with companies from Israel as well as US, where we will be having a TOT kind of a structure. Similarly, you will see there's a lot of foreign companies who will start investing in the Indian drones ecosystem. They could be in the hardware, they could be in the software, they could be in the manufacturing sector. Plus, also you will see that some of the state governments have also started the drone parks and the drone corridors. So there is a huge corridor which is coming up in Salem. So all these things are actually enabling the drone ecosystem players. Could be a software company, could be a hardware company, could be a manufacturing company, and it could be a services company or a training company to be in these areas. So these are the various opportunities which is growing, and please be in a reminder that the entire sector is only it's very nascent. We have only 3 companies which has gone into IPO. there are at least around more than 50 to 60 good companies who are actually getting into the sector with various technologies, because people in the defense will not come to the agriculture. People in agriculture will not go into the service sector because they have got different domains. Each of the sector is a huge ocean. For instance, as I said, agriculture itself is a $3 billion market. You need at least 300 drone players to capture this $3 billion market. So that's where we are. So there is a big room for other drone companies to operate, provided they are able to get the business model, the scale, and the grassroots analytics is done correctly over there. Similarly, you will see a lot of funds being created to actually invest in drone innovations. So some of the big areas which I see in the next 5 years is that India would closely need around 75,000 to about 1 lakh drone pilots. So every drone ideally require two pilots, which is a pilot and a co-pilot. So we are talking around more than 1 lakh pilots to be trained. Plus, you need drone technicians, drone service centers across India. Same like your LG and your Samsung and your car thing, drone is going to make a big change, which means that there are a lot of career opportunities for your mechanical engineers, electrical engineers, and aerospace engineers to be part of the technicians and the service providers and the service centers. In terms of software students, they can actually get into image processing, crop analytics, image analytics, get into the software development, upgrades, which is also a big fish and a big area. So not many companies are focusing in this area. And I believe this is a big area for all the software students to actually get into it, coupled with AI and ML, because eventually there's a lot of data which will be coming out in terms of the structural data from a plant or from the mining industry or from the agriculture industry. So this data will now be patterned by a machine learning, eventually giving out an output which will be good for the end user. Similarly, I would say compliances. Because the drone is coming under the civil aviation and not coming under the motorway, so all the rules which is applicable for an aircraft and an helicopter comes here. So which means there are totally 150 checks before the drone actually flies, and there are around close to 50 checks when the drone is actually flying. So not many people are able to do the compliances. So there is a big area where engineers can actually get into the compliance standard and then become a compliance engineer for a drone company. Because again, the compliance standards for an agriculture or a defense or a oil and gas is completely different, which throws a big ocean for the people to learn and then be in this trade. Similarly, I would say journals. So in fact, I'm also the co-editor of a blog called Mad Times, which is mad about drones. I published more than 15 articles. So there not many players are able to write aerospace in the layman terms. So which means that foreign companies, investors, mutual funds companies, large family houses, all your banks and your what is third party companies, they want to understand this aerospace and the drones in a layman terms. So if you are able to write the electronics of a drone, the training part of a drone in the layman terms, they are willing to pay. So these are several areas where I see a big growth in terms of training, in terms of service providers, in terms of image processing, in terms of journals as well as compliances over there. So similarly, there is another gray area which nobody is focusing in. So we are talking about simulator experts because each pilot requires at least around 40 years of training. So which means that you need a lot of simulator experts who come from an electronic background or an aerospace background. You will see, because it's a nascent sector, you will see a large amount of funds getting into R&D. So which means that you need thorough doctorates in aerospace engineering. Similarly, as you move forward, as we get into more and more data patterns, if once we understand how the crop behaves or how the railway track behaves, you will get into new product innovation, which means that you will see a lot of experts coming into this area. Similarly, a drone has got around more than 40-50 parts, so you will see indigenization happening up. You will start you will slowly reduce the imports coming from other countries, and you will start into local manufacturing, which means that any aerospace or a mechanical engineer will slowly get into the parts manufacturing companies and get a job there. So there are similarly testing. Not many people do that as of today. Only aerospace engineers are able to do the testing. But then, if you take a separate course and if you really focus into it, you can also become a testing engineer. Same like how you do a car testing or a bike testing before the product is sold out. So these are all very, very niche, unknown angels, a gray area where people can also focus rather getting into a drone innovation. So there are many areas to look at it, and the next 5 years, this is going to become a big area, because whenever the government is actually supporting a sector like your manufacturing, your mobile phones, or cars, or EV, it's going to boom. So off late you will see that there is a drone DD scheme which has come out where 15,000 drones are going to be given to the self-help groups, which means we are talking around 30,000 pilots, 15,000 drones, at least 3,000 service centers, then the product sales team, flight controllers. So that's where it is starting. So the government is also giving subsidies to agriculture students, to the FPOs, and in this ecosystem players, and several government banks are also giving loans at 4%. So this is a growing sector. Feel free to ask me any questions in the sector. I am thorough in some areas. I am very weak in some areas as well. So more than happy to answer any Q&A. I was trying to finish the entire presentation on time. So that's why I try to keep it,
Thank you.
so that my next the panelists can take it from here. So if you have any questions, feel free to post it. And if you want, please read the
Yeah.
book. You will start laughing. Yeah, some 800 books have been
Wonderful.
sold within 45 days. So it's quite a hilarious book. Yeah, feel free to talk to me anything,
Wonderful.
anytime. And yeah, I can take one
Yeah.
or two of the questions if you have.
Okay. Thank you so much, sir, for such an inspiring and insightful drone ecosystem presentation. And yes, our young students must have all been very much inspired. I'm very sure they will love to connect with you. We'll have your mail ID posted here so that like, they can connect with you on that. Having like we have other panelists waiting because of shortage of time, we'll move out from the
Yeah, yeah,
questions and answers. And
sure.
yeah, we'll
Thank
have
you.
your mail ID shared here, please, sir.
Yeah, thank you. Yeah,
Uh,
bye.
Thank you. Thank you. It was a pleasure having you. So we
Thank you.
have our CEO, Mr. Shrikant here. Thank you so much, sir, for being here. He's always been a very great forerunner, a very visionary man, making so many impossibilities come true for ICT. He is here to deliver his inaugural address. Sir, please.
Yeah, good morning. Good morning, everyone. I think if you're
Wonderful.
able to hear me.
Yes, sir. Clear, sir.
Yes.
Yeah, good morning. Thanks, Mr. Madhu, for your initial talk. And welcome to Dr. Ramesh Singh and Mr. Vipin. And thanks to Raghav Srinivasan and Linda for initiating this thought leadership series. Sorry, morning I had my small itches in getting connected. So that's why I'm coming as the second speaker of the day. Anyway, this is a new initiative that we have started today, and we are also happy that we are actually focusing on electronic system design manufacturing. So we thought that this particular sector is going to grow well because there is a huge opportunity in this sector, because the governments also, even the private industries also, almost all the top major companies like Tata's or the Murugappa Group, I think even Foxconn, I think they're all making a huge investment. EV is going to be the biggest future. As Mr. Madhu was presenting about drone, I think that is going to be the one of the biggest, uh, what to say, the career growth for the students. So we are also sensitized about this issue by the ESDM Sector Skill Council, Electronic Sector Skill Council. So we are also driving into getting some courses shortly will be launched based upon that. So we are also trying to do a talent pool management. Based upon this, we are going to have the faculties trained, getting into some sort of a COE arrangement with the institutions across India, and wherein the institutions can get tied up with us, where we will be able to bring the industry experts to your campus and getting yourself faculty and the students certified. Based upon that, you will be able to move forward to create some employment in a particular line, going double-digit growth. So that is what we have found. I think it is very, very apt time that this series has been launched, and I hope the deliberations will definitely enthuse the participants, and we look forward for a very strategic tie-up with the panelists going forward from now onwards, ensure that there is a good lot of strategic relationship. Also, some sort of an industry institute interaction takes place in the coming months. And definitely, I think this is a new area, and it's an emerging area, and it's a very highly growing area. In terms of the manpower requirement or in terms of the opportunity, I think there is a huge, what to say, in fact, as I was keep on reiterating that it's a double growth strategy. It's growing in the double growth, and the employment requirement is huge, starting from an diploma to graduates to researchers. The participants to look into this in a bigger way and take it forward in a very motivating times. Thank you so much, and thanks Raghav and Belinda for connecting on this. Thank you all. Bye.
Thank you. Thank you. So it was indeed again a very
You are under
big
mute.
No, you are audible, Miracle ma'am.
audible. Okay. Thank you so much, sir, for your words of encouragement, your words of inspiration. You've always led us in the right path, and you've always made us realize that nothing is a big thing, nothing is a very big, great initiative. Anything is possible when we just believe, and with your support, we have been accomplishing greater things. Thank you for letting us do this, and yes, sir, we'll continuously
I'm
move
not
us.
able to hear you.
Uh, okay.
You were audible, ma'am. There may be some
Audible?
issue with the cancer. Yeah.
Okay. Yes, sir. Thank you so much, sir. And now it's up to Dr. Ramesh. He has received his bachelor's degree from REC Hamidpur. Sir holds a
Linda, I'm
PhD.
not able to hear you. You are under mute.
Sir, hello.
You are in mute.
I can hear her. I can hear her.
You are audible.
Sir, the others are able to hear me, sir. Yes, sir. So we have Dr. Ramesh here. He holds an international patent and 3 Indian patents in his name. He has so many research papers published. He's working with Tata ELXSI. He's a corporate product management group, and he has an overall experience of more than 25 years. That's a very rich experience, I should say. He's the senior member of IEEE USA, and he has been serving as ambassador of IEEE Smart Cities USA in India for such a long time. It's a pleasure to have you, sir, and the dais is all yours. Please, sir.
Thank you very much, ma'am. First of all, thank you, ICT Academy, Miracle ma'am, Shrikant sir, and all the other panelists and the attendees over here. It is a pleasure for me to be a part of this talk series, and I'm really thankful to all of you. Without taking so much time, I'll just start sharing. Is it visible, ma'am?
Yes, sir, clear.
Yeah, thank you. So today's topic that I'll be speaking on will be about electric vehicles, how the technologies have evolved in the various years, and what are the various features that are being incorporated nowadays, and what are the new milestones that are going to be achieved in due course of time, and how this electrical vehicle is going to be disrupted by various other technologies which are nowadays in feature. So starting with EVs, very common thing, whichever is powered by an electrical motor that we call as an electrical vehicle. It can be obviously the drone that we said is obviously an application of those two-wheelers, three-wheelers, four-wheelers, heavy trucks, trains, and all those things come over here. They are basically combined in the form of road and off-road kind of segments. So pictorial representation, if you see, so pictorial representation, if you see, it is a battery which is controlled by a BMS or MCU or VCU. And this is giving power to the electrical motor depending upon the throttle of the driver. and the wheel is being rotated. This is a pictorial representation of an electric vehicle. Now, the various types of electrical vehicles that are presently in market are normally battery electric vehicles, which are other than plug-in hybrid electric vehicles. Then comes the hybrid electric vehicles, fuel cells, and the extended range electric vehicles. These are also coming in the part of hybrid only, but given a separate name for some different R&D purposes also. So coming to the battery electric vehicles, these are powered by batteries, and the examples are basically Tesla, and the previous example was drone, that is also coming in this one because we are using batteries for powering these motors, and this power is being given to the wheels, and so on the power is transferred. The plug-in hybrid vehicles, PHEV, can combine an IC engine also, and they can combine an EV also. So this is a form of hybrid electric vehicle where the battery can be recharged from the AC source also, either it is a three-phase or single phase, and it can be charged from uh, in engine also, which is using in IC. This is what the hybrid one. The examples are Toyota, Pyrus, Honda, Ford, Fusion, and all these. Now, this is a new trend which is coming up. This is a fuel cell electric vehicle where fuel cells are being used. Commonly, we have seen hydrogen vehicles are nowadays in news, much of these. So these are coming in these kind of things. The best part of hydrogen or electric vehicles is that the residue or the outcome is purely water. So no such kind of emission is there. And likewise, we move forward for driving the vehicles. Extended range vehicles are a common example where PHEVs are using a different kind of combination of a battery and a small engine. The ratio of the IC engine and the battery varies depending upon the application, and so on the vehicle is being driven. So sometimes it may be the battery packer may be small, sometimes the battery pack may be more, sometimes the IC engine may be small, sometimes it may be more. It is just to give an extra range because normally, if we see, we are in an era where a transition for the sustainability of transportation is a major issue, and everyone around the globe is working for that. But the thing is, we have not so much infrastructure for the charging facilities or the battery swapping facilities, which are the two common right now sources for charging our EVs. So the hybrid or the extended range electric vehicles are more prominently over here. Some other features of the series hybrid electric vehicle are there where IC engine is also there and battery is also there. So both of these combine and the power is finally given to the motor or wheels, basically you can say. The engine is basically used to generate electricity, which can be used for charging the batteries. And the life of the batteries, you can say, if for a single charge, if we used to go for 200 kilometer with the help of this engine, we can go up to 350 or so on. The components of a series hybrid electric vehicle may combine of a IC engine, electric motor, a battery, a generator, and a control system. Pictorial representation may be also given, whereas an IC is a series hybrid in a typically very small sized. It is just used for charging our batteries kind of thing. The parallel hybrid electric vehicle, which is a combination where the complexity is somewhat more from the control point of view, because here we are giving the power to the wheels both from the IC side and from the electric motor side. Obviously, electric motor is being driven by the batteries. So the combination when to switch from IC to electric motor and when to switch from electric motor to IC or use both of them in what ratio, that the control algorithm is a more complex one as we talk of the series one compared to the series hybrid. So the main purpose of propulsion is electric motor in series electric vehicles, whereas in parallel electric vehicles, it can be both of these. It can be an IC or it can be a electrical motor. The battery in a series hybrid electric vehicle is generally charged by the IC or it can be separately charged by a AC source also. The generator is used to produce electricity which is giving power to the electrical motor and it can be also used to charge the batteries. So the control system of a series hybrid vehicle, which I say is combining when to generate how much amount of power from the IC and to charge our batteries. So its purpose is basically to optimize the efficiency and the performance of the whole EV. The pros and cons are the fuel efficiency is improved, emissions are less, but the disadvantages are that it is less efficient on long drives as compared to the parallel hybrids. So these kind of vehicles are well suited for city driving, where we can have a city drive in Bangalore or Chennai or Guwahati or Bombay, anywhere, or Delhi kind of situations. So this is the structure of a parallel hybrid, and it is what is combining. It is having an electric motor, or it can also act as a generator. Right. So IC engine is again used to run the wheels, and it is again can be used to operate or charge the EV batteries also. The motor, it can be acted as a generator because nowadays a regenerative feature is also there, where if you are on a down road and you have no need to give power from the motor, so this motor goes on regenerative mode, and the excess power which is stored in the inertia or the air gap, you can say, is being transferred back to the battery. So you can increase the efficiency and the overall range from a fixed battery, what you see, it can be increased. The battery is what is used to store the charge. And in parallel hybrids, these battery packs are used to energy storage. They can be stored or charged from the generate motor, which is going to generating mode also, or it can be also charged from the outside source. This is the most complex part of the parallel hybrid one. This is a power split device. Some people call it as a power control system. Basically, it's a control part. So which ratio, what ratio, when to switch on which part is the main factor. And this involves a very complex kind of algorithm. So someone who is very good in power electronics and control systems, so these are the parts where the best of the brains are being used for these things. The pros and cons of parallel hybrids are the fuel efficiency is more, enhanced performance is there, but the disadvantages are that the maintenance and the repairs are very much complex and costly. Moreover, since the control is very much complex, the control system or the power split device is very much costly as compared to the series hybrid kind of thing. The new developments that I was talking of in the terms of EV technology are nowadays the reduction in the cost of batteries. See, the previous year we had a cost of 220 USD per kilowatt hour, and right now BYD and all these companies, they are making an agreement of $50 per kilowatt hour. So that is the huge difference where the prices of the battery are being reduced. The more efficient and high life cycle batteries are now coming in picture. Hydrogen cells are being used in EVs, India and abroad also. And the sodium cells are also having a prominent feature because the major part of batteries is that nowadays what we are using is lithium. And lithium is basically a major source which is confined to, you can say, China. You can say 74% of the whole thing is coming from China. So it has a dominancy kind of thing, and the other rest of the whole worlds are depending on that. So sodium is a kind of thing which is readily available across globe. So this is also coming in picture. Although the energy density and the power density are not as such compared to lithium, but the supply chain issues are very much good. Aluminium is also a major factor which Hindalco and other RDSO are working on these kind of energy sources. We are also using composite materials for the whole building structure of the EV, for the motors and the battery packs. So which will make our whole EV system a lighter one and more flexible and rigid. In the terms of motor technology, we are having a numerous kind of new motor winding configurations. Hairpin is one of those, which increase the current density and overall the power density of a motor. We are also having coreless motors, which are used in EVs nowadays. We are having a new kind of motor technology which is not new in the field of electrical machines, which is an axial machine. Basically, all the machines right now we use are of radial nature. It is depending upon the flux interaction between the stationary part and the moving part. Here, the axial fluxes are there, and the best advantage of these motors is yes, the energy density is at least thrice of the radial flux motors. This is the next part is AI. Now AI is giving a disruption all over the world. It is giving a disruption in medical. It is giving a disruption in transportation also. So right now we are using AI to some extent. Right now in Tesla has gone to level of autonomous level of 3 they are trying, but startup in India is there which is funded by NASA, and it is right now, it is a startup of Bhopal. It is going up to autonomous driving level of 4. It is driving its vehicles on the road of Bhopal and everywhere in the villages and all the roads. So this is one, the autonomous driving is one of the feature. Next feature is how to control the whole EV. Suppose something goes wrong. So before it goes wrong, suppose let it be a case of motor. So usually what motor happens, some fault happens, and after that only we come to know, okay, this fault has occurred. And then we take it to some sales or repair office and maintenance shop, and there we get it repaired. So there is a loss of time, more money is incurred, and overall it is a very ineffective way of that. So AI is coming to play a role over there. It is going to predict a fault between the battery or motor or whatever kind of structure in an EV some 500 to 1000 hours before. So you will come to know on your dashboard ki, okay, your motor is subjected to a bearing kind of fault in next 500 hours of running if you do not go for a maintenance, predictive maintenance. So this is another example of disruption by AI. Earlier, EVs were only used in road segments, but now off-road segments in agricultural sector also EVs are being used. Now, another thing is we have the technology of BLDC, PMSM, induction motor, synchronous motor, and all these. But synchronous reluctance motors basically work on the reluctance part, whereas the other motors work on electromagnetic torque. So there is now combination of both of these, and new Tesla technology is coming. They are giving that in their vehicle, which is incorporating both reluctance and the electromagnetic torque. So it increases the energy density and the power density of the whole motor. So this becomes a lighter motor which can give more power or throttle to the whole wheel. So these are some of the new developments in the EV technology. Finally, I would like to say that since the whole globe is going for the sustainable transportation and it is an issue. So we have moved from IC engine and we are slowly, gradually progressing in the terms of EV. But the two major block bottlenecks which we still have are the rare earth magnet and the lithium. So rare earth magnet extraction is also not so much sustainable in nature. Moreover, lithium also goes with the same story. So somehow, somewhere the other parts which I discussed are coming in picture and they are playing a role of non-rare earth kind of permanent magnets and non-lithium kind of battery energy solutions. So various electrical motor solutions and the battery solutions are coming in picture. AI is going to play its role and the configurations of the whole EV is going to change in next 5 years, which I see now. And with the advancements, we are able to achieve, and we are very much sure that Tata Elxsi and Tata Motors, all these are working on that. We will be able to use a sustainable kind of solution which will incorporate from the extraction to the last mile on the road, a sustainable kind of solution for the EVs. And that's all. I will give a break and my lecture over here. It was very short, but I'm so sorry. I made it very quick one. Miracle Man. I'll give a break, and if any questions are there from the audience or anyone, please come up. Hello.
Hello.
Am I audible, ma'am?
Yes, sir. You are audible.
Yeah, I just finished. I made it a very quick one.
Okay. Okay, so sorry. Okay. Wonderful, sir. It was such a inspiring and right from the starting of how e-vehicles and the prospects of e-vehicles, it was I'm very sure all the students here, all the academicians here were immensely benefited, and you opened a wide scope for everybody. I'm very sure, like they'll pick up all these sparks that you've put here, and in the recent years, we will have great ignitions of taking place. Thank you.
Thank you very much, ma'am. So, shall I take a leave, ma'am, if it's like that?
Sure, sure. Thank you so much, sir. Thank you for your
Thank
precious.
you, ma'am. Thank you, ICT Academy, and pleasure to meet all the panelists and the attendees. Sometime we will connect later on in a brief
Sure.
time, right? Thank you. Have a
Yes,
nice
sir.
day. Bye.
Thank you.
Thank you.
Thank you, sir. Bye bye. Yeah. So we have the next speaker. Rajendra is here. Rajendra, sir.
Just one kada vada.
Thank you so much, Rajendra, for joining us. So it's such a pleasure to have you here. A very brief introduction about Mr. Rajendra. He has been a very result-oriented with 18 plus years of experience in TNEB. And presently, he's working with SIPIM. And it is such a pleasure to have him because like he has worked with so many industries like the Thai Oil Clean Fuel Project. He's been with the Havia gas plant. He's been with the Jason Integrated Gasification Combined Plant. And the list is too many here to read out. So he's been working with the smart plants for quite some time. So we'll hear from Mr. Rajadurai. Over to you, sir.
Thank you, Blandina. Thank you. Thank you all. Good morning, all. Yeah, sorry for the short notice. Actually, yeah, due to some busy schedule, actually, I can't be able to join in time.
That's okay.
And
Thank you for
first of
being
all,
here.
yeah, yeah. Actually, yeah, for the past 18 years, I've been to power sectors actually, purely in design oriented, actually, completely designing and commissioning actually for both power plants and process plants, everything actually. This is what my current profile actually. I'm leading a project right now for Imingom. It is a ammonia to green hydrogen project. That's what I'm handling. And one more project that is in Israel, that is Haifa ammonia plant. I'm handling these two projects actually. I'm the lead. Previously, my profile it is something like digital coordination. Actually, it is purely for smart plant electrical and for SAP oriented material management module and digital electrical load list. This is what my profile actually I'm handling. I'm working with our Milan counterpart actually. Actually, first of all, I need to introduce my concern actually. Things it is SIPAM India projects. This is a headquarter. It is in Italy actually, Milan. Um, Here actually the scope actually the project everything actually mainly they are taking from Milan only, Italy actually. Here we are doing actually splitting the works actually from Milan and Chennai too. This is what our working profile actually here. They are doing mainly oil and gas and chemical plants actually. This is what our current profile. And okay, today actually, as Blandina said, actually, I'm taking about the brief introduction about smart plant electrical, which is a core software for our electrical design field. Actually, I think so many people you are aware about this. And wait a minute, I will present my screen about this. Yeah, is it visible my screen?
Yes,
Hello.
Rajesh. It
Yeah.
is.
Okay. Yeah, smart plant electrical. This is an Oracle-based software. Actually, this is US militant software. Actually, basically, this is for uh, to do the electrical load list, load summary, and even though transformer sizing, everything actually, cable list, cable profile, everything, complete electrical management software. Actually, this is apart from the short circuit studies. Actually, this is the cable sizing and load summary. This activities, entire electrical activities we are doing in this software only. This is a modern version. Actually, we are using that like Excel. It is a modernized version. Actually, that's what. Mainly the software actually we are using mainly for data management first of all, and some of our overseas clients like Saudi Aramco and ADNOC, these clients everybody Shell other and other clients like British Petroleum, everybody they are asking in smart plant electrical model. Actually, once we are starting our project, everything we are planning to do all these things actually from the electrical load list, we are transferring this to Spell. And once everything we are completing the project, actually we need to move a database. Previously, in olden days and all, we are giving a paperwork, lot of actually tons of papers actually we are giving. Nowadays, this is not at all accepting by overseas client. They are asking everything it is in the data bank model actually like smart plant electrical we need to move this complete data bank to client. This is what the thing actually about the introduction of Spell. This is an intercraft product actually which is handled by our US team actually United States actually, and this is the current version SEL Smart Electrical Limited actually. So this is what we are using version 10 and HF 27 is the service pack. This is mainly, as I already said, actually, this is mainly for maintenance and EPC projects, plant owners and designs. Everything it is completely managed in the smart plant electrical only. This is a complete software like SLD creations and it is a complete setup. Like I think you may aware of ETAP software for short circuit system studies. Actually, same profile. Actually, here also we are doing like SLD and cable profile. Everything we are doing in this smart plant electrical. Actually, this is now okay. We need to move on to the next slide. This is a smart plant take part a new generation software based on the database and operation and facilities. Spell allows to the allows to perform electrical plant design and increasing the database actually. This mainly the software application. It is for managing the documentation, electrical engineering, and the entire plant life. Everything it is in the cycle. Yeah, this is what the deliverable list we are planning to do in the smart plant electrical. Electrical equipment data sheet, load schedule, motor power and user summary, single line diagram, wiring diagram, and cable schedule, MTO, and PDB schedule. These are all the complete deliverable list. Now, one more thing actually, like ECMS, that SCADA IO list also, input output list also, we are extracting from the smart plant electrical. That much of clear detail we are planning to do this in this smart plant electrical. And this is the spell hardware and software requirement, like minimum hardware requirement actually required for this software installation. And for to import all this load list, everything actually we are using this Microsoft Excel. And one more thing for other than like we are MDB file we are creating in the Microsoft Excel itself actually. These are all the additional softwares required to perform this activity. Yeah. The smart this smart plant structure, it is something different actually. We are I think anybody from EPC background, anybody actually you may aware about the work-based location. Actually, we are doing the project everything. Uh, this is the complete plant, and this is an each and every module area by area we are creating, and each and this blue color this square everything, it is WBS. We are using a code called WBS. It is work-based service location actually. This WBS wise actually we are segregating. This is what the hierarchy we are creating the load list everything from the smart plant electrical, like plant area unit complete. This is what we are creating in the spell. Yeah. In the smart plant electrical, actually, there are this kind of managers are there: catalog manager, data dictionary manager, options, format, rules, and import manager, and other thing like smart plant electrical engineering manager. But this among this managers actually mainly for to create the database and extracting the like for example, actually data sheet everything we are extracting in a client format means we need to create a data sheet actually sample data sheet. We need to upload it blank data sheet with the use of formats everything in the format manager. Rule manager, it is something like we need to create a cable profile everything we need to create it. And import manager, it is we need to import all our electrical load list from the Excel file to this actually. This is what it is mainly for uploading the documents actually, uploading the list actually, load list. These are all the managers required for this spell software. And this is a typical representation of this file actually, smart plant electrical. This is what the things actually. Here you see RD, reference data explorer. Here we need to track all this information to electrical engineer is the we need to create all this SLDA like cable everything we need to create it, and load list everything we need to attach everything, each and every load list we based upon the feeder requirement, everything we need to create in the electrical engineer. Electrical index, it is whatever we are creating the electrical cables which needs to come here. We need to change the rated voltage, frequencies, everything complete based upon the client requirement. We need to create all this information in the electrical index actually. This is what things actually, pictorial representation actually, just for information. I just paste the screenshot of the software. Yes. Now, what is electrical index, reference data explorer, and electrical engineer and property window? I'm explaining now. Yeah. RD, it is reference data is used to standardize and simplify the project creation. And this is mainly for cable reference data. Actually, based upon the owner requirement, we need to create the reference cable. For example, what are all the cables we need to do, and what are all the types of cables, and what are all the voltage grading, and each and everything, construction, everything we need to give in the cable reference data. Typical circuits, it is nothing but actually for incomer, bus couplers, and outgoing circuits, everything we need to have it in the typical circuits. Profile, it is something like motors. There are three types of load is there. One, it is motor load, other electrical equipment, and heaters. This is what the hierarchy we are following in oil and gas sectors. That kind of profiles actually we need to create. For example, for motors, what are all the additional cables or additional circuits we require, we need to give. For example, space heaters and other control cables, anything is there. We need to create all those profiles in the profile management. Lookup table, it is something, what are all the types actually, number of ratings. For example, how many, there are, for example, motor ratings, there are IEC, ATEX certification motors are there. For IEC, 2.2, 3.5, and 5.5 kilowatt, 11 kilowatt, and 22 kilowatt. There are set of standards are there actually. That standard we need to give it in the lookup tables in the proper way, and we need to select in the reference data explorer to drag the to bring the motor everything in the electrical engineer. Data can be applied in the batch mode to large number of items. Actually, we need to create a set of bunch of loads, and we need to drag everything into the electrical engineer. Yeah, this is what the pictorial representation for lookup table. This is what wiring equipments, typical circuits, profile, lookup tables, and typical blocks, everything. It is like this is what the hierarchy. And profile is a data specification tool that allows to join the loads in the electrical equipment with the specific electrical elements as given an example: motor, space heater and related power cable, control stations and related control cables. This is what the hierarchy we need to do for each and every loads. Yeah, typical circuit permits to define mainly about the feeder and incomer circuit and typical circuit. Yeah, electrical engineer, actually this is to manage the electrical association among the equipment. As I said, actually we need to drag all this information, for example, motor loads and other electrical equipments, everything, bring it to the electrical engineer. We need to drag and connect all those information in the electrical engineer. Actually, this is one of the main thing. Otherwise, if for example, if we not properly connecting the loads in the concerned boards, actually the load summary, it will be creating a wrong information actually. So it is one of the important thing actually we need to do as per the single line diagram. We need to connect each and every load in a correct boards in the electrical engineer. Electrical index, actually electrical index is the window where the project electrical loads and electrical system network items are created and stored and managed. User has to manage all the electrical items. Actually, once we create a complete set of index, actually we can do the entire project in a correct way. Actually, normally here the role, there are different type of roles are there for the smart plant electrical: admin, user level, admin and manager and user level. There are three set of criteria are there. Normally this electrical index, actually from the very first of the project itself, admin, they will ask for the what are all the catalogs, actually what are all the symbols we are using, what are all the types of loads, whether it is IEC motors or ATEX motors. That kind of information, preliminary information, we need to give to the admin. They will create all this information in the software itself, and they will do all such things, everything in the smart plant electrical. And once they give the access to the manager, and the manager need to approve the user level requirement. This is what the hierarchy we are following here. Yeah. These are all the electrical equipments: motor and motor with heater, loads, converting equipments, it is transformers, common features, property window, create subfolders, electrical loads, static loads, heater and equipments. These are all the different type of electrical equipments we are using in the smart plant electrical. And for example, this is the motor load and motor, what are all the things? This is the item tag, which is a unique criteria we are giving in the uh, uh, Excel actually. And once we are importing all this information, motor rated power, brake horsepower, rated voltage, full load current, everything, they will actually full load current is a calculated value. We need to give the preliminary information like brake horsepower, particular power of the motor, everything actually we need to give. Yeah, this is what spell administrative roles, as I explained earlier: handling all administrative aspects of spell, managing spell license, creating project database, creating macros for report customization, supporting electrical department with any database and performance related queries. Actually, this is what the admin role. And reports, these are the generating report, report writer, running custom report, reports option, edit reports, swift reports. This is an admin role only nowadays. Actually, here we are moving this complete setup, everything to the admin role only. Yeah. We can able to create a single line diagram in the, now client is asking for either previously we are doing the single line diagram everything in the AutoCAD or MicroStation, this kind of things that we are doing. Now client specifically asking the single line diagram in the smart plant electrical itself, because the user level actually schematics, everything, it is very easy to prepare the schematics also based upon the SLD. So nowadays they are asking this one. So we need to, before we are starting the project, we need to customize all this symbol managements, templates, and other things like wait a minute, other things like PDB requirements, everything we need to give it in the uh, portal, like reference data explorer, we need to modify it. Yeah, this is what the integration actually we can able to integrate like ETAB and smart plant 3D and smart plant instrumentation diagram. Everything we can able to integrate in the smart plant electrical. For example, during the system studies, we are creating the SLD. Once we are creating the SLD, we need to connect. We will connect, integrate this into the spell, and we need to do any additional work. Actually, we need not want to do any additional work in the smart plant electrical like load import and SLD creation, everything we just move this ETAB information to the smart plant electrical itself. This is an additional add-on advantage actually, because each and every software we are connecting in a single software means it is very easy to move all those information like load summary and other things we can able to do the things in spell. It is in a very easy way. Yeah, key benefits and features. Engineering tool to increase the productivity, better quality deliverables, data sharing, reuse of skills and expertise, reduction in cost through the data consistency, standalone and multi-user configuration by plugin application to the SP smart plant models, support of major commercial database, permit integration with SPA, EDSA. These are all the softwares we are using like system studies and other things, all which of uses to share the data with the third-party softwares. Yeah, this is what about smart plant electrical. And career perspective, now I think you may aware for oil and gas, it is a there are very actually for example actually we are running out of actually all this employee management. It is very difficult now. There are nobody is there for this field actually, because everybody is going for software. So for engineers like for smart plant electrical, there is a huge demand for this, like for admin roles and user level. There are so many things are there now. There is a Integraph itself actually, they are taking some specialized training programs for this. There is a certification program is there actually from Hyderabad. They are running for this training and other things. So if anybody wants to move to core field, actually, smart plant electrical, it is one of the best option to come to this oil and gas, because actually, apart from the experience, if you know the smart plant electrical itself before having you have nothing, you are a fresher means you just learn the smart plant electrical itself, oil and gas field will they will call you actually. This is one of a very good software actually for basic learners also. So that's what my end. If any doubts, please raise. Thank you.
Thank you so much, Mr. Rajendrai, for making all the participants and academicians here and even people from the corporate, all the participants know that like somebody who says like electrical could always be thinking it's only holding all the high voltage tension cables and all that, but here like when you put it out, it was so much like so smart things that are happening here, all like management side as well as the administration side. Like once the installation is complete, I think the whole monitoring and upkeep is being
Yes.
done in a very smart way. That is so wonderful. And you presented that so wonderfully to all the participants here to like even I was like individually benefited, I should say that everything was so meticulously put, like where and of everybody comes in and how everybody can contribute towards it. And you rightly pointed out by saying like people moving towards software, too many people moving towards the software has left a vacuum here in this field. uh, there was one question I should say, like if it's okay to, how can an IT student move to a smart plant electrical? There are any specific courses available? That's a question I think. Even software students, like once they've moved into it, they do feel at the end of the day. But like, can you have an answer for that? An IT
Uh,
student to smart
yeah,
plant electrical.
sure. Yeah, smart plant actually for now, uh, HCL, everybody actually, whoever in software actually, they are doing this same activity for admin roles. Actually, they are doing the same activity. So once they need to move from IT to here, smart plant is the best choice. You need to go for an Integraph, just 1 or 2 months actually. This is a online class itself available. You need to go and you just straight away you just come back to switch over. It is very easy actually. This is what my
Wonderful.
concern. Yes.
Wonderful. Thank you so much for your
Thank you.
precious time. Thank you
Thank
for
you.
being in spite of all those glitches and you had to travel away from your place. And thank you so much. And Preeta
Thank
is
you.
so with your answer and she says thanks as well. Thank you so
Thank
much,
you.
Mr.
Thank you. Thank you.
Thank you. Thank you. So we have our next speaker here is a very young and energetic man, Mr. Vipin Karana. He is the director and the founder of R Cube Green Technology. Green has been his heartbeat, I should say. So he is into the design engineering perspective, the research and development, the manufacturing and process engineering, the supply chain operations, as well as the business development and strategy. He is an army of people with so many IoT based greenhouse monitoring systems that he has developed, the soil moisture indicator, and the tension meter for research facilities that he has developed, so many fitness tracker wearables that he has developed in house. We are surely going to have history of experiences from him. Thank you so much for being here, Vipin, and over to you.
Yeah, thanks, ma'am, and thanks to everyone here, and thanks for inviting me here. And I would like to also thanks Rakel, ma'am, ICT Academy, and Srikant sir for giving me this opportunity and to share seat with such a well-experienced panelists here. So I will begin my presentation here. So let me share my presentation. So is my screen visible, ma'am? Am I audible?
Yes, yes, you're audible, Mr. Vipin, and your screen is also visible.
Okay,
Thank you.
thanks, ma'am. Thanks. Yeah, so today is my topic that is which is one of the I think most important topic as per the current government initiatives, that is in India's role in semiconductor industry and as per current global state of ICs. So first of all, I would like to introduce myself. My name is Vipin Karana, and I am director and founder of RQ Green Technology LLP, and I am also owner at Yashoda Libraries and Co-working Space. And I also previously from 4 to 5 years, I have been working in this field of embedded systems, and I have gained my experience in hardware and firmware development. And I also received grant from TBI Kite and the grants Nidhi EIR, Prayas, and UP startup policies. And I think that from these grants, I was able to develop multiple things, and I will get that amount of time. And for that, the products which I have and products as well as the projects which I have been developing for in-house and for my clients as well. For example, the IoT greenhouse monitoring system. So this project we have developed during the lockdown period, and it is for one of the clients, that is the H2O Greens. And we have developed the soil moisture indicator and tensiometer for various research facilities, and we have also delivered to IIT Palakkad and some research institutes, for example, Biomol India, Shield Biotech. And currently, I am working. So we are as a team working on a platform to support working professionals and startups, and we are developing basically a platforms so that the startups and passionate learners, so they are able to choose the right IC for their product based upon our research and based upon our understanding of this particular field, that is electrical and electronics. So mainly we are focusing on the devices, for example, the smart home devices, healthcare devices, particularly the chips or the technology which one startup or company or the working professional which they need to learn. Like for in example, in EVs, what kind of ICs are required, and they are also which are also being used by the famous companies like if I talk about the Amazon Alexa and the Google Home speakers, what kind of ICs they use particularly. So we share our insightful experience, and our documentation will help the startups there as well. So let's begin about understanding what is semiconductor manufacturing. So, manufacturing, semiconductor manufacturing is basically manufacturing of microchips, transistors, diodes, and integrated circuits for making PCBs. For example, the smartphones which we use, the
So can
computers.
we have it in the full slideshow mode, sir? Vipin?
Okay,
Uh,
okay, ma'am.
yeah.
Okay. So is my screen visible, ma'am?
Yeah, it is visible. Just
Okay.
that it's
Okay, 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 okay.
slideshow mode.
Okay,
Yeah.
ma'am. Yeah, it is fine,
Yes,
ma'am.
yes. Thank
Okay,
you.
so yeah, thank you, ma'am. So let's understand in two basic ways. So what is semiconductor manufacturing? For example, if we talk about like there are in simple terms, we can say that the PCB manufacturing starts with the front-end processing, where the silicon substrate or the silicon serves as a substrate for manufacturing of semiconductor devices, and it involves various steps, series of steps like oxidation, photolithography, etching, doping, and deposition, from where the PCBs are created or fabricated. And the other, then the next step comes is the packaging or the assembly, and that is the back-end processing. So, for example, here in this, we can see that the SMT lines they produce for example, the PCBs in the smartphones in the around the 40 to 50 seconds. All the PCBs for single PCB, it takes 40 to 50 seconds, and there are multiple operations which are done in the SMT lines. For example, we can see in this slide. So it is a whole SMT line. Here there are multiple machines or the operations which the assembly line does. For example, is a PCB loader. Then first the PCB the slate or the steel plate is manufactured or it is fabricated, and the solder paste is spread over this stencil, and there is a pick and place machine. For example, for example, as we can see in the screen, so this is a complete line and it costs approximately 20 to 25 crores for the single line. So it requires a huge investment as well. Then comes the pick and place machine where the components like resistor, capacitor, and all the transistors, these are placed, and the machines are so fast that we can't even able to see with our naked eyes. And I've also given the opportunity and to work in a company, Chinese-based company, that is the HiPad. So there I get to learn and understand how the SMT line or the surface-mounted technology works. Then there comes the air reflow oven. So here the PC, all the soldering paste and all the components which are placed over the PCBs, they go into the air reflow oven. So it is a very high temperature like chamber. So all the soldering paste and all the components they get soldered perfectly in that air reflow oven. So which it and having a temperature of more than 400 to 450 degrees Celsius, and it is a very high temperature. And then the inspection is done. In the inspection is done, it can be manual, it can be with the help of instruments. So this is a complete semiconductor, how semiconductor or the PCBs are manufactured for like smartphones and for like computers or EV or trackers. So this is a complete understanding of how semiconductor uh, is manufacturing is done. Then let's come towards like the current manufacturing capacities of ICs by countries. So let's understand what are the dynamics. So currently, as we can see in the chart, Taiwan dominates manufacturing for logic chips, and it accounts for more than 55% of market all over the world. So Taiwan is currently the major manufacturer of the ICs, integrated circuit, PCB. So as we can see, so here the chart it explains that below 45 nanometer and up to below up to 10 nanometer of technology, or the PCBs are fabricated by majorly by the Taiwan. But here TSMC and Taiwanese companies, they are a contract manufacturer, means they manufacture for other companies and other countries, and majority of these countries are US based. So they are actually not they don't actually own IP. And for India, so there is a plus point. And along with manufacturing of semiconductor, India can dominate by creating its own intellectual property like the US does. So I think we need to work on developing our intellectual properties and technologies and researches in this field. So by that we can dominate, as our Prime Minister Modi ji said, that we need to work on the development of the research and the development facilities. So let's understand what the percentage share of companies owned by countries. So as I was previously explaining, that majority of the companies like Intel, Micron, Qualcomm, Broadcom, TI, these are all US based companies, but Taiwan manufactured their ICs. So majority of the profits, they go towards the ICs, but Taiwan manufactures them. They are contract manufacturers. So not only we need to have a manufacturing units, as there are multiple setups and multiple government initiatives, and I will explain in the further slides. So we need to also work on the research and development aspect and developing our own intellectual property as well. So, but Taiwan-based companies produce the most, as I said, semiconductor devices for like companies Broadcom, Qualcomm, Nvidia, and we all know that Nvidia a top 10 around the world. It is a $1 billion company. We all know that most of the AI, artificial intelligence, cloud computing, these are done inside the NVIDIA chips. And there's also plus point for India as well, that the proposed plant will manufacture the high performance computing chips. And we are able, now we are planning to develop a 28 nanometer technology, and instead it was proposed earlier that we will manufacture 40 nanometer chips. But now we are progressing towards 28 nanometer chips or technology. So these are the recent major investment of India in semiconductor. So the government has approved major investment in semiconductor and electronics products project production. So, and I think we all are aware uh, uh, in the recent news that government of India is taking investment, and uh, I would also, for that, I would also contribute towards the ministers. They are highly educated ministers in our industry. They are from IIT. They are IIT alumni as well. So I think I believe that there is a bright future for the semiconductor industry in India. And for example, so there is a one semiconductor fabrication and two packaging and test facilities which are developed. And the government has approved $42 billion investment. And talking in terms, it is a 1.3 trillion rupees in terms of rupees. So it is a huge investment, which the government of India in. For example, Micron Semiconductor Unit, it is in Sanand, Gujarat. So there are two plants. For example, the first mega project under the government's $10 billion, and there is an investment of $10 billion in that plant that is situated in Gujarat. And there is a Micron technology, and it is for packaging, like package assembly, like the SMT line, which I was previously explaining. So it is a $2.75 billion packaging plant. And there is a partnership between Tata Electronics, as we all know, Tata is leading. It is a multi-conglomerate company, and it is a brand itself. And so there is a partnership between Tata Electronics Private and PSMCs, Power Chip Semiconductor Manufacturing Corporation, and it is also established in Dholera. And I think previously there are multiple projects which are coming in Dholera. It is going to be a major city, and there are multiple smart cities, and there is going to be, it is a huge, I think, a city is going to be developed, and it is covering high performance chips, and there itself, it is a 28 nanometer of technology is being developed in the Dholera site. So, chips which can be manufactured in India, and as per the ministry report, and the chips at Dholera. So there are eight broad sectors in which the ICs are going to be developed, like including the high power computing. And we all know that high power computing is for example, weather forecasting. There is a huge amount of data which is required. So supercomputer chips, high performance computing. Then electric vehicles, as we all know, so electric vehicles is uh, now itself is a huge market, and there are many multiple players, and it is and one of the examples is Tesla. It is one of the uh, major companies which is leading in electric vehicle domain as well. So is telecom, defense, consumer electronics, automobile, and power electronics with 28 nanometer of technology. So at Dholera site, there is a projected capacity of 3,000 wafers per month. So one wafer can have roughly of 5,000 chips in it. So practically, this unit will produce million chips in a year. So it is a huge number, and it is said by our Minister of Union Electronics and IT Minister, that is Ashwini Vaishnav, and I have also given like I have also seen him personally, or I have also had a chance to uh, heard his speech at when I was previously or so with projected. So this side, it will create a huge number of jobs, like 12 lakh jobs are projected in the next 4 years. So there is a great opportunity for engineers, operators, technicians, technical and not from non-technical background. So there is going to be a huge jobs which are being created. So I think the currently the engineers and the PhD scholars, they have a great opportunity in semiconductor industry as well in multiple fields. So what the advantage India currently have? So we have a talented pool.
We'll just hold on for a moment. There's some glitch from the speaker's side. Please unmute yourself, Mr. Vipin. Please unmute yourself. Yeah, we are able to hear you. Yeah.
Ma'am, you are able to hear me?
Yes, yes, yes.
Okay, okay. So sorry for a small glitch.
No, come on. You can continue, please.
So I will continue. So
Yeah.
So, as I was previously talking, like there is a talented pool of skilled engineers, and it from in the field of electronics, electrical, and computer science. So, many engineers are they are well trained in VLSI design, and we can take advantage from Tier 1 and Tier 2 colleges as well. So, and there is also an existing player. So there are multiple existing companies here which have a research facility and research and development centers inside India. We have an advantage. For example, like the Intel, Qualcomm, TI, Broadcom. So they have a research and development centers inside India as well. So these are some of the advantages which India currently have. So chips which can be manufactured, and there is, as I was previously mentioning, that there are multiple government initiatives. Like the Indian government has launched initiatives like the ESDM, and that is to promote the growth of semiconductor industry in India. And I myself have got government incentives in terms of funds, like as I was previously mentioned, and I think it is a great thing for the Indian startups and the working professionals to develop their own talent, their own intellectual properties. And there are incentives for setting up semiconductor fabrication units and the research facilities. So, and the other advantage which we have is the startups and the collaborations, and promoting startups in India, focusing on aspects like the semiconductor device and including the intellectual property development, the tools and fab lab chips. And and one of the advantages is currently we have is a stable government, and it is having a vision for the next 5 years, 10 years, and 15 up to 20 years. So by 2035, we are projected, or the government is projected, that India will lead in every domain. So they have that sense of responsibility or vision they have. So, and there are multiple foreign interest or for FDI investment, which we are seeing. For example, currently UP, and it is a $1 trillion economy in itself. So it clearly shows that how much determined we are towards developing. Uh, so there is also strong diplomatic and geopolitical relations with the other countries. So we are very much strong in our opinions, in our statements, as like there are like strong ministers, as we can see currently. So what the challenges do we have, or the Indian ecosystem faces? Like there is a huge amount of infrastructure investment which is required for developing fabrication facilities, and it requires significant investment in infrastructure, including clean room facilities, specialized equipment, utilities such as water, electricity. And India needs to enhance its infrastructure to attract semiconductor manufacturers to establish their fabrication labs, fabrication facilities in the country. And there is also require a skilled workforce. In terms of there is a shortage of skilled professionals and specialized areas. Example, the analog and mixed signal design, RF design, EDA tools, and we need to improve the quality of education and providing specialized training programs. And it can help bridge this skill gap which currently we are facing. And we need to have departments which are more focused in the niche domain. So, and there is also need in the advancement in research and development. Like the semiconductor innovation requires robust research and development capabilities with a long-term vision. For example, it is not just a 1 or 2 year game. It is a 5 year plan. So we need that amount of investments so that the engineers they need to have that amount of incentives and the work culture there. So India needs to invest in more in the research and development initiatives for indigenous semiconductor design and technologies. So more research intensive institutes like IIT, triple IITs, and IITs are required. So, and there is also necessity of intellectual property protection for encouraging innovations, attracting investments, and I think the incubators they are currently. For example, I got support from TBI Kite, so they have their own intellectual property. They are guides and there are consultants there as well, which help startups and guide like how to protect their intellectual properties, and there are global competition as well. So India is facing a challenge from Taiwan. For example, I was previously mentioning it holds 55% of the market, and India needs to focus more on its niche market. As we all know that IT and software, we have a strong hold on that, and I think we need to develop more and attract semiconductor companies in India. So India needs to attract more semiconductor companies to develop their research facilities in India as well. So, and I will like to talk. So there are multiple career opportunities for the engineers or the students which they are pursuing their masters and their PhD. So, for example, now PCB design. So, as we all know, it is a physical layout of PCB foundation footprints. So, tools like LTM Designer, Eagle PCB, KiCad. So, student needs to work on their research, and they need to work like I have experience in multiple softwares as well, not just about theoretical aspects. So we need to work on our core technologies or core design or software tools. Like example, CAD, and we all know that CAD it has a multiple application in mechanical, electrical, architectural design to develop an enclosure, for example, PCBs, and we all like, for example, the mobile phones or the remote controls. So they need a certain kind of enclosure, certain kind of retrofitted enclosure, or the design customized enclosure. So students the learners or the engineers, they need to have an understanding of CAD design. So multiple software they need to like SolidWorks. So there are multiple softwares as well, and there is a for example in hardware design, so development of circuits and systems including component selection, schematic design. So it is for prototyping. So I personally have invested so much amount of time in developing prototyping, in learning all these tools. So these tools help me understand to get a better understanding of how this semiconductor, these products, how these products are manufactured, what kind of technology is required. For example, the electrical EV, like for example, the smart watches or the IoT systems. I have majorly working on the IoT, Internet of Things devices. For example, telematics and the soil moisture indicator. So I got to learn so many different tools, so many different prototyping capable tools, for example. So it requires an understanding in analog and digital circuit design, understanding semiconductor devices, familiarity with microcontrollers, different type of microcontrollers we need to learn, prototyping development, knowledge of tools like LT Spice, Designer, PCB softwares. So these are multiple skills which we need to learn. And over a period of time, when we dive in deep inside the research and prototyping stages, so there we get to learn like how soldering stations work, how oscilloscopes actually work. So there we get a real understanding of these uh, tools. So there is an opportunity for research scholars as well. So research in various disciplines like semiconductor, embedded systems, IoT, Internet of Things, and that is for real-time operating system. For example, currently the startups which are working in food delivery, for example, Ola, Swiggy, they all are using real-time operating systems. So we are able to track real-time locations of these devices or these the delivery agents. So how we are able to do all that? So this is all because of the startups. So they actually are developing or moving our technology. So there is a scope for in wireless communication as well. Like we are using in our home, in our offices, the 5G technology as well. So we all have fiber optic cables inside their research facilities as well, inside the colleges. And so talking, for example, the manufacturing and process engineering, there is a demand in manufacturing and process engineering as well. So there are multiple methods and tools which we need to learn to work in the manufacturing and processing engineering, and it requires product efficiency, and cost effectively. So it involves the design optimization, control of chemical, physical, and biological processes used in manufacturing. So these certain skills which we need to develop. So, and for example, the industry 4.0 and smart manufacturing. So there is a need for the students to learn all these things, integration of like how digital technologies such as IoT, cloud computing. So how these are all done in industry 4.0 in IoTs. So there is a huge amount of scope for students in this field as well. And there is also opportunities for non-technical jobs like supply chain management. So all the manufacturing units, they require a certain kind of managers, floor managers, area managers. So there are multiple career opportunities or prospects for the engineers, for technical, for MBA students, for managers. So there is a huge amount of opportunity in the semiconductor. So I think and I believe there is a bright future for semiconductor manufacturing in India, and India is going to lead the manufacturing sector. So it is going to, like, there is, as we all know, there is a shortage of ICs globally. So India will fulfill this. For example, in the recent, as we see that during the Corona times, we are able to manufacture mass amount of vaccines. So in the Western media, so that the Western media says that India is going to be in huge loss in the Corona times, and it won't able to save. And we have seen that India not only fulfill its need, it also supply to other countries as well. So there is a bright future for India in semiconductor industry as well. So here is my small team, and there are consultants. For example, I am a founder, as you all know, as I just previously mentioned, co-founder, and so there is a Jiten Sharma. He's also co-founder, and he works in sales and marketing. And there is a Rishabh Kumar, so he's our mentor as well, and he's also working. So we have multiple industry professionals, and I have personal connections with them as well. So thanks from my side, and I would like to invite questions here as well. So based upon my understanding.
Thank you so much, Mr. Vipin, for that very insightful and sharing your journey with us, starting with semiconductor industry, the opportunities that lie there, and the immense interdisciplinary potential that India as a country has developed over time. Thank you so much. And if we have any questions, we can take them. Otherwise, like, we'll just have the questions posted on the chat. We have our Raghav sir here. Thank you so much for being here, Raghav sir. And it was his conceiving of this thought as this Thought Leaders Talk series, and we are here with the first one today. And we'll have such quality talks happening over fortnights. Over to you, sir, for the vote of
Yeah,
thanks.
thank you so much, Miracle. Thank you so much for putting it together and organize this event in a very, very professional way. Thank you so much to you. And it's my privilege to express gratitude to all the speakers. Those who have given us a lot of inputs about the electronic system design, manufacturing industry, and the electric vehicles, and the growth of this particular industry. How effectively it is going to impact in the near future. As everyone knows that like India is considered to be the next electronic system design manufacturing hub, and the entire global market is started focusing towards India because of two important facts. That one is the skilled manpower, and the second is the component is on the wages, right? Like when you talk about the daily wages of Indonesia or Vietnam or the other countries, where India is far like I would say cheaper than those countries, where the or industry or the organizations, those who are in the electronic system design manufacturing, or be it electric vehicles, they started focusing on our skilled manpower. One second important component is the I would say like the supply chain. What India is having now, right now, is far better than the other countries. So the company started focusing on that, and my I would say the chairman used to say one word, that if IT is going to provide us 5 million jobs by 2030, this electronic system design manufacturing industry is going to give us 10 million jobs. That kind of a growth India is going to witness in the days to come. So there are plenty of opportunities are available for the diploma holders, engineering grads, as well as the arts and science graduates. I'm able to see more number of arts and science colleges are also participating this the thought leadership talk series. You are also having lot of career growth in the electronic system design manufacturing. Watch very closely on this electronic system design manufacturing industry, where you will be able to get the jobs. I'm able to see in the chat box, what about the certificates? You are not only going to certificate, you are going to get jobs as well, right? So when you're closely watching this kind of a series, thought leadership talk series, your jobs are guaranteed, and you are going to get a fabulous career ahead of you. That's the point which I thought I'll just share it with you. And my heartfelt thanks goes to our CEO, Mr. Srikanth, for accepting to host this particular program through the virtual platform. After various discussions and deliberations, we were able to organize the first thought leadership talk series today, and it is going to continue. And our intention is to ensure that we are bringing the best of the best resources across the globe. Today we started with the resources, technical resources from national level, where this will grow to the level of inviting the resources across the globe. And thanks to our CEO for accepting to host this program first. And our gratitude goes to Mr. Mathu, the Chief Growth and Investment Officer of Garuda Aerospace, for giving us so much of support. He's not only joined us for this particular session, where he has also accepted to be a partner for ICT Academy and host few of the faculty development programs in the aerospace, very specific to drone technologies. I would say, like, there are a few training programs are going to be organized by ICT Academy, very specific in drone technology, which is going to be supported by Garuda Aerospace. And thanks goes to Dr. Ramesh Singh as well, Senior Product Manager of Tata Elxsi, where we are trying to explore the possibilities, and we are also trying to explore the synergies with Tata, not only with Tata Elxsi, with the entire Tata Group, where I hope you know that Tata is creating a very big facility in Gujarat to provide more number of placement, as well as like contributing their services in the electronic system design manufacturing. We are actually excited to get associated with Tata in the days to come. I am seeing this as a first step to get associated with Tata. Thanks to Dr. Ramesh Singh for accepting our invitation to be a keynote speaker. And thanks to Mr. Rajadurai Ramachandran, in spite of his busy schedule and personal commitments, he was able to make it for today's session. First program of us on TLTS, Senior Principal Engineer from Saipam. Thanks to you, sir, and thanks to Mr. Vipin. Personally, I like the entire session, Mr. Vipin. Thanks to you as well. You have given us a lot of insights on the ESDM domain, and students must have enjoyed the program as well. Thanks to you, as a director, founder, RQ Green Technology. I would like to express my heartfelt thanks to Mr. Vipin Karana for his excellent session, and thanks to all the colleges for nominating their children for participating this program, and I'm pretty sure you have enjoyed the program, and you'll continue to participate such kind of a webinars, and ensure that you're getting a lot of insights from ESDM domain, AVGC industry, animation, visual graphics, comic industry, as well as the life science industry, and I would say smart manufacturing. These are the four industries growing multifolded, where ICT Academy wanted to be a front runner in that space. Last 14-15 years, we focused more on information technology industry as well as information technology enabled services. Now we wanted to focus more on these four various avenues, which are going to create more number of employments. I'm repeating: electronic system design manufacturing, AVGC, animation, visual graphics, comics industry, life sciences industry, and the smart manufacturing industry is going to create a massive wave in the country, and each and every house will have an employee working in this four of this industry in the days to come. Right? You are going to witness that. But ICT Academy wanted to be a front runner in that, and I would like to wish and thank all the college managements as well as the students fraternity, those who have joined us the program, and my colleague Ms. Blandina for putting it together. I just conceived this thought and given that to her. From there, she has taken it forward and ensured that this program has been organized very, very professionally and very well. And we have got tremendous response from the corporate as well as from the academic fraternity. Thanks to you, Blandina. Looking forward to meeting you all soon with the next session. And I'm guaranteeing you will receive a feedback link once the session is over. Once you update the feedback link, automatically you will receive the certificates that will reach your mailboxes once you are completing the feedback mechanism. That's what we have created. Thank you so much to each and everyone those who have supported this first session of Thought Leadership Talk series. Thank you so much.
Thank you. Thank you so much, in the honor, Sir Raghav, sir. It's such a pleasure to have you all, and yeah, he has done everything for us. And yeah, we'll have the feedback link shared, and once you fill up the feedback link, you will receive your certificates. So that is the process that was very clearly stated here. Thank you. Looking forward to host such innovative programs in the near future, and have a blessed day. Thank you so much.